Hey guys, welcome to another episode on Kind Spirit Tech. So today we are going to cover boxplot with GGPlot. The purpose of boxplot is same as with violin plot. Actually, those two are often used interchangeably. The purpose of both is to represent value distribution over categories. And boxplot in particular could be quite difficult, especially if you have never been into analytical data or into some kind of statistics. But once when you learn how to read it, it's going to become both easy and handy. And for the purpose of this tutorial, I have this piece of data. We have three columns. In first column, we have a place of measurement or category. In second column, we have actual value, and in third column, we have index of measurement. And now let's create our box plot. So we are going to use data as our data source, and with aesthetics, we are going to say on x-axis we are going to cover index. On y-axis we are going to cover value. We are going to group it by place, and we are going to fill it by factor of place. Okay, plus and add GEOM BOXPLOT. Run it. So this is basically how boxplot looks, but in order to explain it better, I have to add few things. First, I'm going to remove this legend with theme legend position set to none. Let's run it. So legend. Okay, this is much better. And now let's add some dots in order to represent our actual values or observations with GEOM jitter. Jitter is actually same as GEOM dots. So color is going to be black. Let's say size 1 and alpha also 1. Run it. And now I'm going to add some labels to these dots in order to read actual values. With GEOM label, with aesthetics we are going to say that text is going to be actual value. On X we want to set our label to be on index, and on Y is going to be on value, but minus 0,25. So I want my text to be actually below point, so we could see everything quite clearly. Okay, this looks nice. Save it, run it. Let's see what we are going to get. Okay, this is fine. First we are going to observe this green one. So first thing that we are going to notice is this vertical line from bottom of our box, and then this vertical line atop of our box. So what are those? First of all, the dot at the end of our bottom vertical line actually represents the lowest value observed, so that is 0 in this case. And the top of our top vertical line represents the highest value observed, and in this case that is 2. And now size of the box, it's not the same in all of three cases. It depends on actual values. And how so? First, bottom line represents 25% of all values. Top horizontal line represents 75% of actual values. So all of dots above this horizontal top line are actually values above 75% of all observed values per this category. All of values below this bottom horizontal line are below 25% of all observed values. And what about this middle line? In order to understand that, imagine that you have like 11 observations or 11 values and you arrange them from lowest to highest. this middle line would be sixth value, because in that case it would be equal number of observations below and above. And as you can see, this middle line, it's not on the same place in all of three boxes. So in this case, our lowest point it's at 0, highest point it's at 2, and our middle point it's at 1. So 1 it's in the middle, so that's completely fine. But check this second box, it's a red one. So we have a lowest point at 1 and highest point at 3,3. And our middle line it's actually at value 2. So why is that? Why it's not a little bit higher? Because 2 is the closest observed value among all of observed values per this category. We don't have any other value that could replace this one. So guys, this could be tricky to understand at first, but give it some time, do some practice, and you are going to become master of it in no time. So I truly hope that you have learned something interesting, so please like, subscribe, and see ya!